We're going to start off this course by reviewing some of the fundamental skills and strategies and concepts that we felt that you should be pretty comfortable with in order to be successful in this course. These are all things that are going to come in handy down the line as we start exploring different types of functions, which is effectively what pre-calculus is about. It's an exploration into the types of functions and how they behave and understanding their graphing properties. So we're going to start by talking about equations because I think that's a good launching pad into exploring working with different types of functions. So first off, knowing what an equation is. An equation is simply a statement that two algebraic expressions are equivalent. And I'm going to abbreviate a lot here. Two algebraic expressions are equivalent. Right? I'm just using that equal sign there, which is typically a binary operator just to indicate that we're setting two different sides of our numerical statement or algebraic statement are equal to one another. So when it means to solve an equation, what we're looking for are values that make this mathematical statement true. So for example, in number one, we're asking ourselves when we're trying to solve here, what are the values of x such that this mathematical statement is indeed true, that this polynomial that's on the left side is indeed equal to 0. Well, there are a number of different ways to do that, and even as I go through this lesson here, there are going to be some problems where you may not approach it exactly the same way, and that's fine. But I want to go over a couple things that I think work well for me, and hopefully they will for you as well. So for number one, we're going to factor by grouping. And so what that often means is trying to find common factors in the terms. So for this first problem here, I'm just going to go ahead and highlight these first two terms. I notice that I can factor out a common factor, 4x squared, so that we're left with just x plus 3. And with the remaining terms here, I'm also looking for common factors. And I notice that I have a common factor of 8. That's my GCF there. So I've got 8, and what's left over is x plus 3. And what's key here is this. What we're looking for is a common factor once you've actually grouped them. If we don't have a common factor here, we can't proceed with factoring by grouping. That's not to say we can't finish solving this equation in some other way. We just can't use this particular method. But since I see an x plus 3 there, I'm going to go ahead and factor that out. And what we're left with is 4x squared minus 8. And you can factor that if you want, but it doesn't really matter. Because at this point, we see that the zero product property allows us to set each one of our factors equal to 0. So this x plus 3, we know then that results in an x value of x is equal to negative 3. And I'll write this one out. We got 4x squared minus 8 is equal to 0. That means 4x squared is equal to positive 8. If I divide both sides by 4, x squared is equal to 2. And then x is equal to root 2. Now, you might be a little alarmed here. You might be thinking, Mr. No, what about the plus or minus root 2? And I would say you're absolutely right. We do need that plus or minus. But I would challenge you to really think about why we need that plus or minus. If, say, for example, I said x squared is equal to 4, I think a lot of us have been taught to solve this by extracting the roots, which is a completely legitimate method, which is just take the square root of both sides and then say the square root of 4 is 2. Oh, but don't forget about the plus or minus. So let's throw that in there. And what happens is that plus or minus becomes kind of a secondary thing. And the danger in that is that one, we might forget to throw that plus or minus, but it also kind of doesn't really give us a good sense of why we need that plus or minus. It's just something that's thrown on at the end. So instead, I would challenge you to really think about these, and although you can extract the roots, to actually think about this as the following. X squared minus 4 is equal to 0. We want to actually group all the non-zero terms on one side. And when we solve it this way, we actually see that we should be getting two factors from this. And what's really nice about this method is that this leaves no question as to whether or not how we get both positive and negative 2. It's pretty clear to us by factoring and solving and using the zero product property that we should be getting two zeros there. So it's important for that reason because we want to make sure we understand that when we have a quadratic equation, we should get two zeros or two roots or two solutions. That's not to say they will all be real solutions, but it's important to know how we get there. So in the same way, when we get something like x squared is equal to 2, think about this as x squared minus 2 is equal to 0. And we get x plus root 2, x minus root 2. And that's a little bit of a tangent there, but I think it's important for us to know exactly where that plus or minus is coming from. So I'm going to go ahead and clear that out of the way. I'm going to also go ahead and box my final answers, which you should be doing in this course, to clearly indicate to the reader that these are my final answers. And that's going to be really important, especially when we start talking about something called extraneous solutions. Let's look at number 2 now. For number 2, we're going to solve this using solve an equation that has fractions, specifically where the variable is in the denominator. There are a number of different ways that you could go about doing this. And one thing that I might propose here is to actually solve this by multiplying both sides by the least common denominator. In this case, that would be the product of the two denominators that you see there, x times x minus 2. So if I go ahead and multiply all of this entire equation, both sides by x times x minus 2, I'm left with, on the left side, those x's are going to divide out. So I have 2 times x minus 2. On the right side, I'm going to distribute that x times x minus 2 to both of those terms. So those x minus 2's are going to divide out in that first fraction. So I'm left with 3x. And we're going to continue. We're just going to multiply our LCD by -1. So we have minus x times x minus 2. Now, at this point, it's just basically combining like terms. So 2x minus 4 is equal to 3x minus x squared plus 2. And it doesn't really matter how you move everything around. I'm going to have my leading coefficient be positive. So x squared minus 3x minus 4 is equal to 0. And that should be factorable. And it is. And what that does is it results in the following solutions. X is equal to positive 4. That's what will make the left side equal to 0. And also x is equal to -1. These are the values that make this mathematical statement true. All right, now let's move on to an absolute value equation. So with absolute value, if, for example, I gave you something like the absolute value of x is equal to 6, well, what are we saying here? We're saying that x could be equal to both positive 6 and negative 6. And despite what some of you may think, absolute value does not just mean make the number positive. That's not what absolute value implies there. Absolute value is simply your way of measuring its distance, the number's distance from 0. How many units away from 0 is that number? So when it says the absolute value of a number is 6, if we're saying, hey, positive 6 has a distance of 6 from 0, so does negative 6. So positive 6 has a distance of 6 from 0, and so does negative 6. That has a distance of 6 from 0. So what that means for us is when we're solving an equation with the absolute value, we want to know we have to understand that we can have both a positive and negative inside that absolute value. Now, what that results in is two separate equations. We want to first say x squared minus 3x is equal to -4x plus 6. In other words, as it's written. But we also have to understand that what's inside this absolute value could also be negative, because when we take the absolute value of that, we get -4x plus 6. Now, I can write it like this. So let me write it one way here. Right? What I could also do is just make the right side negative as well, which is equivalent to just dividing both sides by -1. It's going to result in the same thing. So I'm just going to go ahead and also show that here. So if I divide this right side by -1, I'm now going to get 4x minus 6. Sorry about that bell there. So I get 4x minus 6. And I'm going to solve both. I've got x squared plus x minus 6 here is equal to 0, I believe, which allows me to factor this as x plus 3 times x minus 2 is equal to 0. And that results in x is equal to -3 and positive 2. Over here, I got x squared minus 7x plus 6 is equal to 0, which then gives me x minus 6, and then x minus 1 is equal to 0. And that gives me two solutions of x is equal to 6 and positive 1. Now, I haven't boxed any of my answers, and there's a good reason, because I haven't checked to see whether or not my solutions are all valid. Do they all work when I plug them back into my original equation? So, for example, something like -3, when I plug that in, you can quickly do the math there. We see 9 minus 9. The absolute value of that would be, or excuse me, 9 plus 9. That would give me 18 there. And then on the right-hand side, we've got -3 times -4. That's positive 12 plus 6. That also gives me 18. So -3 works. But which values would not work? Well, let's start with something like positive 2. Let me just write this out. The positive 2, I see that on the left side, I get 2 squared minus 3 times 2, which is 6. On the right-hand side, negative 4 times 2 plus 6. And this right away should give you some pause, because negative 4 times 2, that's negative 8, plus 6, that's negative 2. In fact, it doesn't really matter what this left side is. There is no way that the absolute value of an equation could result in a negative value. So right away, I see that positive 2 is what we call an extraneous solution. It does not work. An extraneous solution is a value that we get algebraically when we solve, but does not actually satisfy the original equation. I would encourage you now to pause the video and see what are the other values, if any, that are extraneous. And now if you've come back, hopefully you found that positive 6 actually was also an extraneous value or an extraneous solution. So the only solutions that actually work, x is equal to negative 3 and positive 1, and that's what we're going to box. So I'm going to now encourage you to pause the video and try number 4, and then ask yourself, can I check for any extraneous solutions? Well, welcome back. I'm going to go ahead and work through them now. I'm going to multiply both sides by my LCD, which in this case would be x squared minus 4. So I'm going to now multiply both sides by that LCD, and what's left over is x plus 2 is equal to 3 times x minus 2 minus 6x. And if I continue solving this here, and that's 4x is equal to negative 8, x is equal to negative 2. You hear that? Brunch is not available today. All right, so I've got x is equal to negative 2. Now, I want to check to see whether or not this is extraneous. So I'm going to check here. So when I plug in negative 2 into my equation, I got 1 over negative 4, 3 over negative 2 plus 2. Well, that's an issue right away. I don't even really need to continue doing this because I know that this results in a fraction where we're dividing by 0. We know that that is not possible. We can't have 0 groups of a number, right? Space and time would collapse onto itself. So negative 2 is an extraneous solution. It doesn't matter whether or not both sides are even equal to each other. We can't even determine that because we get something where we're dividing by 0. So if negative 2, the only value that we got algebraically, doesn't work, then what does that mean for us in terms of our final answer? We say that there is no real solution. There is no value that makes this equation here work. There's no value for x that could make the left side be equal to the right side. So go ahead and pause this video right now and go ahead and work through these 6 problems, and you can check my website to make sure that your solutions match up with what I have. Now, I want to end this lesson by just briefly talking about x and y-intercepts. If you recall, an x-intercept is simply the solution point when y is equal to 0. A y-intercept is the same thing, but this time when x is equal to 0. And remember, I want to highlight here, it's a solution point. It's a coordinate. It's where it's crossing, in this case, the x-axis. I'll write that crosses the x-axis. And graphically, a y-intercept is where it crosses the y-axis. Hence the name, the y-intercept. So let's briefly just find the x and y-intercepts of this equation here. So to find the x-intercept, I'm going to plug in y is equal to 0 into my equation, or I'm going to substitute that in. Substitute 0 for y. This is a pretty simple equation to solve. We get 5, so x is equal to 5/2. So although that is the solution to my equation, keep in mind, this is not my x-intercept. It is a solution point. So in other words, it is this coordinate, 5/2, 0. That is my x-intercept. This is not my x-intercept. Let's go ahead and find the y-intercept. This time it's when x is equal to 0. So we've got 2 times 0 plus 3y is equal to 5. And 3y is equal to 5, so y is equal to 5/3. And again, that means 0, 5/3 is my y-intercept. Now, just to finally close this off, let's talk about points of intersection. And we will spend a lot of time. In fact, we'll spend an entire chapter on points of intersection um, and solving systems, I should say. But for now, if we have something like this where we have a linear equation and a quadratic equation, a simple way is for us to simply set the two equations equal to each other because both of these expressions here are equal to y. So if both expressions are equal to y by the transitive property, both of these expressions should be equal to each other. So I can say x plus 2 is equal to x squared minus 2x minus 2. And this is pretty straightforward to solve. So x squared minus 3x minus 4. And that gives me x minus 4 and x plus 1. So x is equal to 4 and negative 1. Am I done? No, because I have not found the points of intersection. I've solved that equation, but I've not found the points. So let's just substitute these values in for x into either equation. It doesn't matter. But I would recommend using the equation that's easiest. So y is equal to 4 plus 2 seems a little bit, seems like it's a little less work. Y is equal to 6. So that first point is 4, 6. And then we have y is equal to, what is that? Negative 1 plus 2 is the other x value we got. So y is equal to 1. So the other coordinate would be negative 1, 1. Okay? So hopefully through this lesson, you've had a chance now to get a pretty good grasp on different ways to solve equations. And we'll explore more in the next section, B.3.2, and then also reviewing X and Y-intercepts and points of intersections.